All right, now let's talk about writing an equation for a linear function. So to write an equation representing a linear function from a graph, so this time you're given a graph, how do you write the function? You could find the slope either from 2 points on the line, so using the slope formula, you can either use the slope formula given 2 points, or you can count the rise and run on the graph. So it kind of depends on what information you're given on your graph. Sometimes it's easy to count the slope, sometimes you actually need to use the 2 points. Step 2, find the y-intercept, which is b. So that's going to be, sometimes you can just look at the graph and tell where the y-intercept is. Sometimes you might need to use y equals mx plus b, or your point slope formula to calculate b. All right, step 3, plug the values in for m and b in the function. F of x equals mx plus b. All right, so let's do that. Step 1, find the slope. So on this one, it's pretty easy to count. I can just find 2 points where I can tell the line goes exactly through those 2 points, and then I can count the rise over the run. It's going up 3 and to the right 1. So the slope, rise over run, is going to be 3 over 1, which equals 3. Now, a good thing to keep in mind is if you see that the line is increasing, right, it's moving up from left to right, you should have a positive slope. If it is moving down from left to right, so this function is decreasing, you should have a negative slope. Okay, so just keep that in mind as you calculate your slopes and make sure that you have the appropriate sign. Okay, and then find the y-intercept. So on this one, I can tell b equals 2. That's that y-intercept right there. So that one's a little easy, a little obvious. Step 3, plug the values in for m and b in the function. So this is f of x equals 3x plus 2. And there's your function. Number 4. So on this one, I could, count the slope on here, or we could use m equals y2 minus y1, so negative 4. Let's see if I name this x1, y1, x2, y2. You could do negative 4 minus negative 2 over 2 minus negative 4. So negative 2 over 6, which is 1/3. That reduces to negative 1/3. And notice the line is decreasing, so good, I have a negative slope. Now on this one, I cannot tell exactly what my y-intercept is because it's not exactly on a point there. So let's plug one of those points into y equals mx plus b along with our slope. So here's how that would look. I'm just going to choose this point. It doesn't matter which point you use. So this is going to be x comma f of x, right? X comma f of x. So I'm going to do negative 4 equals m, which is negative 1/3, x, which is 2, plus I don't know b. So b is the only thing I don't know once I plug in a point there. All right, so we'll solve for b. So I'll do that in my calculator. I've got negative 4 I'm going to do my negative 1/3 times 2. So then I need to add that to the other side. So negative 4 plus 2/3. Math frac. So b equals negative 10/3. No wonder we couldn't see it on the graph. All right, so then plugging those both into f of x equals mx plus b. F of x equals negative 1/3 x minus 10 over 3. All right, number 5. All right, this one hopefully we see it's a horizontal line, which means the slope is 0. There is no change in y as x changes. There is 0 change in y. So the rate of change is 0. Okay, and then our y-intercept is 3. So as you plug that into the function, you've got f of x equals 0x plus 3. Well, 0 times anything is 0, so that's just f of x equals 3. So this is the line y equals 3, but we're writing it in function notation, so you get f of x equals 3. So no matter what you plug in for x there, 3 is going to be the output. All right, now let's look at graphing linear functions. There are multiple ways to graph a linear function. You can graph it by 1, plotting points. So you could get 2 points. You would need 2 points from the function, and then you could plot those points and then sketch the line through it. Or you could use the y-intercept and slope, right? Just plot the y-intercept, use the slope to count up over and get another point. Or you could use transformations. We talked about transformations in the last unit, vertical stretches and compressions, shifting up, down, left, right. Okay, so let's look at all 3 of those options on 5, 6, and 7. So on number 5, I'm going to use option A, plotting points. You need at least 2 points. Okay, so I'm going to plug in any value into this function. So let's do f of 0. Why not? That's negative 2 times 0 plus 6 equals 6. So I have the point 0, 6 on my graph. And then what if I do f of 5? So it's negative 2 times 5 plus 6. Oops. So that's negative 10 plus 6 is negative 4. So you have the point 5, negative 4 on your graph. Okay, so I'll plot 0, 6, and 5, negative 4. All right, so there we go. So that's plotting the line using 2 points. Now, it is a little bit easier on these if it's given to you in standard form like this, probably to use the y-intercept and the slope. So let's look at that on number 6. So first, plot the y-intercept. I'm going to use a different color. Plot the y-intercept at negative 4. And then you will just use your slope here. So remember, it's rise over run. So this is going to go up 1 and to the right 3. Up 1 to the right 3. And then we can sketch the line through those 2 points. All right, and then option number 3. You can use transformations. So this is interesting. You probably didn't think about applying this to linear functions when we're talking about transformations. But this number here, it is outside of the function, and actually there really is no function to be inside of here. But the 3 is going to cause a vertical stretch by 3, which means you're going to multiply your y values by 3. So that's going to be x comma y goes to x comma 3y. And then this minus 1 is outside as well, so that's going to make it shift down 1. which makes your y values decrease by 1. Now the parent function, the linear parent function, goes through these points here. So if I take, say, this point 0, 0, and I plug it in here, the x is not going to change, and I have 3 times 0 is 0, minus 1 is negative 1. So I would have the point 0, negative 1 on my graph. Now I'm going to pick a different point. Let's do 3, 3 on the parent function. How is that going to change? Well, the x, again, is not going to change. The y is going to become 3 times 3 is 9, minus 1 is 8. So it will become 3, 8. And then you could sketch the line through those, through those 2 points. So that's how you can use transformations to graph a line. Not that you would want to if you have the option, but it does apply. All right, so that's it for your notes on linear functions. Next, we're going to talk about applying linear functions to real-world problems.